We were graphing lines. We have two ways of graphing lines so far. One is the 3-point method. Define three-order pair, 3 points, that satisfies the given equation. And that method always works. The other method we have was the intercept method, which was a faster method, but it doesn't always work. In order to use the intercept method, you must have an x term, a y term, and a constant which is not 0. Are there any there that gave you trouble? Any you'd like to see graphed? No? None? Okay. Let's go on. Today's going to be a very nice, easy day. Now, we said that we need 2 points in order to have a line. 2 points determine a line. So let's suppose I have 2 points. Let's suppose point A is the order pair x sub 1, y sub 1. And point B is the order pair x sub 2, y sub 2. We have 2 distinct points. We have a line. Now what we're going to do for the next few days is talk about the characteristics of this line. One of the characteristics this line has, it has steepness. Steepness. Now the mathematical term for steepness is slope. Slope. And the mathematical symbol for slope is M. Our definition of slope is M is equal to says M is equal to, that's a Greek letter, delta y over delta x. Now in math, or in any area that employs math, such as business, biology, physics, delta means change. That's all it means, change. So slope is nothing but change of y over change of x. Well, let's see. If y goes from y1 to y2, how does y change? What is the change of y? Well, let's put numbers here. If y goes from 7 to 12, how does y change? By 5. How did you get it? You went 12 minus 7. So change is always y2 minus y1. It's the difference. Change means difference. If you're 17 and I'm 31, the difference of our ages is 31 minus 17. If the temperature was 24 degrees this morning and 45 degrees this afternoon, the change of temperature is 45 minus 24, or 21 degrees. Change means difference. So we can say that slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And here we have the equation, the formula for slope. Okay? Let's show you how it works. Let's suppose we have 2 points. 2, 3 is our first point. And let's see, 7, 6 is our second point. We have 2 points. We have a line. What I like to do is find the slope of this line. So what we're going to do is we're going to number these points. I'm going to call this point 1, this point 2. If this is point 1, this represents x sub 1, y sub 1. If this is point 2, this represents x sub 2, y sub 2. So now all we're going to do is plug these into our formula, which is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So m would equal y sub 2, the y value of the second point, that would be 6, minus y sub 1, that's 3, over x sub 2, which is 7, minus x sub 1, which is 2. We get the slope of this line is equal to 3/5. Now slope is never ever a mixed number. It's either a fraction or a whole number. Now what do we mean by slope? We mean change of y over change of x. What this is saying is this line, for every 3 units it climbs up, it goes 5 units to the right. That's all we're saying. For every 3 units up, it has to go 5 units to the right. Now notice what I did in this problem. I called this point 1, this point 2. Would it make any difference if I called this? Well, let's find out. Let's take those 2 points again. And this time, let's call this point 1 and this point 2. And let's see if we get the same slope or a different slope. Well, slope is equal to y2 minus y1 over x2 minus x1. Now notice here, this is x1, y1, this is x2, y2. We plug them in. We get y2, that's 3, minus y1, which is 6, over x2, which is x sub 2, which is 2, minus x sub 1, which is 7. We get the slope is equal to negative 3 over negative 5, which is equal to 3/5. Notice, makes no difference which point you call point 1, which point you call point 2. This line has one steepness. Okay? Let's try some of these, 4 of them. First one. Let's suppose you're given 2 points, 5, negative 1, and 7, 4. You have 2 points, you have a line, find the slope of that line. Okay, what did we find for the slope of this particular line? Wong?
Slope equal 5
5?
and half.
5 half.
5 over 2.
5 over 2. Beautiful. We have 2 points. We call one of these points 1, the other point 2. If this is point 1, this represents x sub 1, y sub 1. This is point 2, x sub 2, y sub 2. It's just a matter of plugging these in. We come out with 4 minus a minus 1. Well, that make it 4 plus 1. Over 7 minus 5, we come out with positive 5 half. Okay? Let's try this one. 2 points. Negative 3, 4 is the first point. 2, 1 is the second point. Find the slope of the line connecting those 2 points. Okay, Lynn, what'd you get for the slope of this line?
Negative 3/5.
Negative 3/5. Everybody agree with that? Sure, that's correct. We get m equal. We call one of these points 1, the other point 2. So our formula says y2, well that would be 1, minus y1, well that would be 4, over x2, which is 2, minus x1, which is a negative 3, makes it a positive 3. And sure enough, we come out with negative 3/5. Very good. 2 more. Two points. 2, 6, 5, 6. You have a line. I'd like you to find the slope of that line. Okay. Long, what'd you get for the slope?
0.
0. Very good. 0 is the slope of this line. Point 1, point 2. So we have y2, which is 6 minus 6 over 5 minus 2. Cleaning this up, we have 0 divided by 3. But 0 divided by anything except 0 is 0. So this line has a 0 slope. Yes, Kathy?
Does that mean that it's 3 units then to the right?
Say again?
That means it's 0 units up and
Right.
3 to the right?
Sure. Sure. One more. Okay, Kathy, what do we get for a slope here?
0.
0?
No.
No. What'd you get when you worked it out?
4 over 0.
4 over 0. What is 4 divided by 0?
4.
No. You can't do it. Remember.
Undefined.
very, very, very important as you go on in math. Remember that division by zero is impossible. You can't do it. It's undefined. So we have m equal 5 minus 1 over 3 minus 3, which is 4 over 0. And we say, hey, since it's impossible, we have no slope. So on the board, we have all the possibilities for slope. We have a positive slope, a negative slope, a zero slope, and a no slope. What we like to do now is show you what each of these lines look like so you know what the slopes are. Our first line is made up of the points 5, negative 1, 7, 4. Our first line. 5, negative 1. That's our first point. Our second point is 7, 4. And there is the line that has a positive slope. Notice what a line that has a positive slope looks like as it goes from left to right. What does it do? Goes up. Therefore, if I draw a line that has a negative slope from left to right, it should do what? Go down, because all we mean by positive and negative is direction. So if positive is one direction, negative has to be the opposite direction. Well, let's find out. Here's our second line. Consists of the points negative 3, 4, and 2, 1. And there's the line. Notice this line, the slope is negative. So a positive slope, the line is going to be going up from left to right. Negative slope, it's going to be going down from left to right. Now the next line, made up of the points 2, 6, and 5, 6. And there we have a line, and the slope is 0. Slope is 0. Again, notice what a line that has 0 slope looks like. It's a horizontal line. It's a line parallel to the x-axis. So anytime they say, hey, you have a line parallel to the x-axis, right away you know its slope is 0. Lastly, we had the point 3, 1. We had the point 3, 5. And there's our last line, and this line we said has no slope. No slope. It's a vertical line. It's a line parallel to the y-axis. Has no slope. Now, if you are going on in math, you get into calculus. Calculus is the study of slopes. And the most important slope in calculus is that line that has a 0 slope. It's going to be the most important. Okay? Let's suppose I have my Cartesian system and I have a point A here on the x-axis, and A is 2, 0. I have the point B. B has the coordinates 6, 0. And suppose I asked you, what is the length of AB? What is the distance from A to B? How far is it from A to B? Tony?
4.
4. Everybody see 4 units. In other words, you have to take 4 steps to go from A to B. How'd you get it, Tony?
subtracted x1 minus
Well,
x2
he's,
minus x1.
he subtracted the x's. Very good. He went 6 minus 2. Could he have went 2 minus 6?
You're asking the distance, so took the absolute value.
Right. We want to guarantee the distance can never ever be negative. Never. So in order to guarantee that, we just take the absolute value of the number. We say, hey, this is equal to the absolute value of 2 minus 6, or the absolute value of 6 minus 2. 2 minus 6 is what, Tim? 2 minus 6.
Oh, it's minus 1.
The absolute value of negative 4 is? 4. Sure. Okay. Now, let's make this a little bit more general. Let's suppose that A has the coordinates x sub 1, 0, and B has the coordinates x sub 2, 0. Therefore, the distance of AB would equal the absolute value of x2 minus x1, the difference of the x's, the change of the x's. So you see, we can find now the length of any line on the x-axis or parallel to the x-axis. The length of any line on the x-axis or parallel to the x-axis is x2 minus x1. Okay, now let's take a look at it now. Let's suppose I have point C here, and point C has coordinates 0, 1. Point D has coordinates 0, 4. 0, 1 for C, 0, 4 for D. What is the length of CD? Or what's the distance CD equal to? 3. How did you get it? It was the difference of the y's. But you want to make sure it's not a negative number, so you take the absolute value. So the distance CD would equal the absolute value of 1 minus 4 or 4 minus 1. Doesn't make a bit of difference. Well, the absolute value of 1 minus 4 is negative 3, which is 3. Okay? Better yet, let's suppose now that C had the coordinates 0, y1, and D has the coordinates of 0, y sub 2. Therefore, the distance of CD would equal the absolute value of the difference of the y's. And there we have the formula for finding the distance on any line on the y or parallel to the y-axis. But that doesn't do us too much good, because almost all our lines are neither parallel to the x or the y-axis. So let's take a look. Let's suppose I have 2 points, A, which is x sub 1, y sub 1, and B, which is x sub 2, y sub 2. And what I like to do is I like to find the length of AB. The length of AB. Okay? Everybody with me? Now what I'm going to do is through A, I'm going to draw a line parallel to the x-axis. Okay? Through B, I'm going to draw a line parallel to the y-axis. Notice they are going to intersect at some point I'm going to call C. Okay? C is a point. That means C has to have an ordered pair. Well, let's see. Now, since AC is parallel to the x-axis, since AC is parallel to the x-axis, what has to be true?
BC is parallel to the Y.
No, I know. Well, no, I'm talking about AC now. And what I'm looking for is I'm looking for the coordinates of point C, the ordered pair that makes up point C. So I know that AC is parallel to the x-axis. What has to be true if this line's parallel?
The absolute value.
No, not yet, not yet.
How about it's half the
Alright,
length?
then y is 0.
Y is what?
Y for C is the same as
Right.
y.
In other words, if this is parallel, this distance here and this distance here has to be the same. The y values have to be the same. This y value is y sub 1, therefore the value of this has to be y sub 1. You're going the same units up, it's parallel. In order to be parallel, you have to go up the same units for both points. Now, BC is parallel to the y-axis. Since BC is parallel to the y-axis, what has to be true? The x's have to be the same. Therefore, the x of B must be the same as the x of C. So there are the coordinates of point C. Point C has the coordinates x sub 2, y sub 1. Now, we know that AC is parallel to the x-axis. And we said the length of any line parallel to the x-axis is the absolute value of the difference of x's. So this is equal to x sub 2 minus x sub 1, the absolute value. BC is parallel to the y-axis, and we said any line parallel to the y-axis is equal to the absolute value of y sub 2 minus y sub 1. Now, figure ABC. Figure ABC is what kind of figure?
A right triangle.
A right triangle. Everybody will know what a right triangle is. Now, in a right triangle, anytime you have a right triangle, there's something that is definitely true. What is that? You remember your 8th grade?
That those two legs are half the hypotenuse
Nope.
times. You multiply the legs and you get the hypotenuse
Nope.
times 2?
Nope. You got the right words, you got the right number, but you did the wrong thing with it.
A squared plus B squared.
Yeah, if you square the two legs, the Pythagorean Theorem. Remember I said you have 3 formulas you use all through math. One was the quadratic formula, the second the Pythagorean Theorem. All the way through math. Anytime you have a right triangle, automatically, a squared plus b squared equals c squared. If you square the two legs and add them together, not multiply them, add them together, you'll get the square of the hypotenuse. What we're saying here is that AB squared is equal to AC squared plus BC squared. If you square this leg plus this leg squared, you'll always get the square of the hypotenuse. Or we can say now that AB squared is equal to AC. Well, AC is x2 minus x1 squared plus BC, which would be y2 minus y1 squared. Right?
Absolute value.
But if you square something, what are you going to always come out with?
Okay.
Positive, so you don't need the absolute value since you're squaring it. Therefore, AB would equal plus or minus the square root of, remember we're trying to take square root of both sides, but we're talking about distance.